is Soumya and I welcome you back to Revisedu, the learning platform. In the previous lecture, we have seen Coulomb's law in vector form. So today we are going to see Coulomb's law in terms of the position vector. Fine. So what is position vector? The question arises. So position vector is simply a vector which represents the position for your particles. And over here, the particles we are talking about are charges, right? Alright, so let us see the diagram on the right hand side so that we can derive the expression for Coulomb's law in terms of position vector. So the diagram over here shows 2 point charges Q1 and Q2 which are moving, but we are assuming that they are moving in Cartesian plane. Why? Because we are supposed to use position vector over here. Fine. If you imagine that a ball is moving in the room, suppose that ball is a particle. So what happens? It will have some coordinates, right? X and Y, with the help of which you can define them. Similarly, when we talk about vectors, what happens is that we have a position vector over here. Let R1 and R2 be what? Let R1 and R2 be the position vectors for. These are the position vectors. Fine. For what? Q1 charge and Q2 charge respectively. Fine. Q1 and Q2 are what? They are point charges. We know that we represent charge by Q1 means Q. Fine. So how we can do is this derivation. If X is the distance, vector X is considered to be the distance between the charge Q1 and Q2. So now we already know that what is the formula for your Coulomb's law that we have done in the previous video lecture. Fine, this was the formula. Now over here, the distance between Q1 and Q2 is defined as X. So the formula can be written as force vector is equal to K Q1 Q2 by X vector magnitude Q. Right? Into what? Into X vector. So let this be your equation number 1. Now the game comes of position vectors. So let us see how we are going to put position vectors in this form. Right. So what we are going to use is, we are going to use the triangle law. You all have studied triangle law of vectors, right? So we are going to apply triangle law of vector addition. So what it says was that the triangle law of vector addition is actually what? That this vector and this vector, the sum of R1 and R2 vector will be giving you the X vector quantity, right? So this is what we are going to write. We can say that R1 vector plus X vector, because we take it in clockwise directions, right? So it is equal to R2 vector. Fine. Now we can say from this equation that your vector X. Why we took it like this? Because R1 and X are in the same direction, while this is in the opposite direction. So this will be in the other sign, right? That is why we have taken it like this. So it will be R2 vector minus of R1 vector. This is what you will get the value of X. So when you substitute this value of X in equation number 1, so from equation 1, by substituting the value of X, we get your vector F is equal to K Q1 Q2 by R2 minus R1 vectors magnitude Q. Fine. And what you will have here is R2 vector minus R1 vector. This is what you will have the expression as. Right. So the above equation can be written as in this form. Right. This is the final answer for this derivation. So this is the form in which we can write our Coulomb's law in position vector form. Why this is position vector? Because both of them, the difference of both of two, define your positions of Q1 and Q2. Right. Because you can simply see that Q1 and Q2 are separated by a distance of X. So what is happening? That using other two vectors, we are defining the position vectors for Q1 and Q2. So here the distance from Q2 and Q1 is considered. Means this is actually the distance of Q2 from Q1. If you have to write it like the distance of Q1 from Q2, So this formula will become F is equal to K Q1 Q2 by R1 vector minus R2 vector whole cube into R1 minus R2 vector. So we have done it for both. When our Q2, the distance from Q2 is taken to Q1, then you will have this. When the distance from Q1 is taken for Q2, then you will have the formula as this. So I hope that this concept of Coulomb's law in vector form in terms of position vector is clear to you. Thank you.